Hello, my name is Grace Lee, and this is Constant Velocity Exploring Systems with a Constant Velocity. So, for a brief introduction, velocity is defined as the magnitude and direction of object speed. Constant velocity, in particular, is defined by no forces in a given system. Velocity can be determined and simulated through different tools such as GlowScript and Tracker. GlowScript is a version of Python that enables a visualization aspect to the program. It is often used for 3D imaging and also used to run simulations. Tracker can track things such as position and time, can have inputs into things like mass, and can measure the center, either center of mass or point mass. The end of the lab saw constant velocity being achieved through a linear slope on the time and position graph and a zero slope on the time and velocity graph. Some important concepts is v final equals v initial plus acceleration times delta t. This can also be written replacing acceleration with f net over m. This equation is primarily used to derive v final, and this equation assumes that the force is constant. The second equation is the position update formula. For this lab, 1 half at squared does not contribute to x final due to the velocity being constant. Finally, the average velocity formula is used by calculating the average displacement traveled over the time to travel said displacement. So why is constant velocity relevant? Many assumptions are made about this lab due to constant velocity. No force. Because this lab involves constant velocity, there is no acceleration. Because the equation for force is F equals ma, there's no acceleration. The use of equations. Kinematic equations require constant force. Zero force is still considered constant force, meaning that these equations could be used in this lab. And this is a visualization of constant velocity. So, logistics regarding this experiment. In this experiment, a battery, 35 centimeter ruler, a scale, and a video camera were used along with previously mentioned software. The system consisted of the battery in motion while the rest of the background is considered the surroundings. The battery is at rest in the beginning of the experiment, and the battery was weighed beforehand and found to be 0.023 kilograms. The 35 centimeter ruler is laid to rest alongside the battery, and there are no forces acting on the system. The battery was given a light push, and the video was recorded until the battery reached x equals 35 centimeters. The video was then cut in order to make the video stop exactly where the battery was at x equals 35 centimeters. This was done for the sake of the tracker. The video was then imported to the tracker software, and the tracker software was used in order to calculate the time and position of the battery through manual or automated tracking, which manual was used for my experiment. Through the data provided in the tracker, two graphs were able to be made. The first graph was the position and time graph, and using the formula v equals delta x over delta t, the velocity time graph was also able to be made. And this is the data. The red line is the best fit line. After the actual data was calculated, GlowScript was used to run the simulation of the experiment. The first picture of the code shows the establishment of initial conditions along with the details of the visualization diagram. The second picture of the code shows the previously mentioned equations and applying said equations to the initial condition. And this is the data provided by the simulation. As shown in both sets of graphs produced by the simulation along with the real data, both show a linear line and a line with a slope of 0 for the position time graph and velocity time graph respectively. Some errors that were presented in the lab was being unable to completely remove the influence of all forces on the system. However, since the best fit line for the velocity was a line with a slope of 0, the data in the simulation are still similar enough for a correlation. This shows that the system was truly in a state of constant velocity with no forces. So for some what if questions, what if in the tracker you flip the x positive and x negative directions? While the velocity would turn negative, as all the positive x's are turned negative, the speed, aka the magnitude, would be unchanged, which still makes the conclusion applicable. What if there's a slight deviation in the scattered points leading not to a perfectly straight line? And as long as the best fit line fits, the conclusion is still valid. Thank you.